Section 414 is called a shunt generator. And shunt is this motor term that, you know, for us, like if we're thinking about circuit analysis, we would have called that parallel, you know, series and parallel. But something, a shunt generator has a field, excitation field that's in parallel with the armature. And we're going to look at that in some detail going forward. So pretty much the rest of this chapter is, you know, we kind of got what's going on, right? We kind of get what's going on inside this DC generator, which is going to apply to all our electrical machines. And so what we want to do now is just look at different construction and many times connection schemes. And most of that is in regard to how the field is connected, the field that supplies the magnetic flux to the machine. And we're going to see that different types of connection for the field circuits will give us different output characteristics for the machine. So what we're seeing here in figure 419, it is what's called a self-excited shunt generator. Up to this point, we had talked about the separately excited generator, and we sort of use that. It's simpler to understand. And so, you know, when we're trying to learn other things, we don't focus so much on the field, but we're going to look at this shunt construction, and we've got two representations of this thing. Okay, we've got the schematic diagram of it, and then, you know, the other is just a, you know, more of a physical representation. So, you know, here's our schematic, and what we're looking at here, here's the armature, you know, and we looked at how all that is connected and constructed. This would be our output, you know, where our two brushes are working to bring us those accumulated voltages. And of course, this is out here where we'll eventually connect a load to this. And this is the field. And anytime we see I sub X, we're thinking excitation current. Excitation current is the current that is needed to create the magnetic field. And we see that it is, you know, absolutely in parallel with the armature. He's trying to show us that again here. And, you know, earlier we had looked at that separately excited, and we actually had this thing that was outside the generator that provided that flux. But now we're looking at something that entirely occurs within the machine itself. And it's really pretty interesting. The principal advantage of this is that you don't need a separate source to provide this excitation. So how does this self-excitation work? Okay, so whenever a shunt generator or parallel generator is started up, there is something called remnant flux that is in the poles. Okay, and he shows that to us on page 81. This thing called remnant flux. You know how something becomes magnetized, and you know you've observed that, you know, through your life. Something actually possesses this magnetism because of something that happened to it. It could have been exposed to an electrical current, or sometimes you can even just physically strike like a metal rod and continue, and it will realign the atomic structure of this ferromagnetic, and it becomes a permanent magnet. But just think about this armature has some remnant flux. It's just there, and it's you know, this remaining leftover, you might say, flux. Okay, so when I rotate this, it is going to create a voltage, because, you know, it's the voltage is there, the conductors are turning, and so this remnant flux there creates a voltage, and this excitation current, you know, is acting, you know, in the shunt field. Well, as I turn this resulting small magnetomotive force, it's in the same direction as this remnant flux, and it causes the flux per pole to increase. And then as the flux per pole increases, the excitation current again increases because it's in parallel with everything, right? And so as that increases, the voltage increases. As the voltage increases, since it's in parallel, the excitation current increases. As the excitation current increases, the voltage increases. And so you get the idea, right? I mean, there's this one affects the other. And so there's this progressive buildup until eventually the armature voltage, the E sub O, reaches this maximum voltage that it can achieve based on the saturation curve. Okay, so that's how a self-excited shunt generator works. Its basic idea here that we want to think about is this remnant magnetism that resides on the armature, and it is there, and it starts this whole thing. And you know, maybe, I don't know, sometimes in class we have a little more time to go through some ideas about things, but I will tell you that one thing that has to be done to a generator is what they call flash the generator. And say it was being rebuilt or it was brand new and it didn't have this remnant flux there, you actually do this thing called flashing of a generator, and that's what you're doing. You're creating this flux that causes this whole process to happen. Okay, so in the next section, we'll go through some specifics of this and go into a little more detail with the operation of a self-excited shunt generator. And again, what we're going to do the rest of this chapter is just work off this basic understanding that we have and look at details of different types of generators going forward.